Okay, hi everybody. We're going to be working on the second section in Chapter 7, and this will be simplifying algebraic expressions. Algebraic expression has variables and numbers in it. So please, we're going to have a bunch of vocabulary words. Write this down in the box, and we're going to keep referring to it with each vocabulary word. Okay. First vocabulary word is a term. Term is something that's separated by a plus or a minus sign. So in this example, the terms would be 3x, 8, 2y, negative 5, and x. There you go. So again, those are the terms in this algebraic expression. Coefficient is a number that's multiplied to a variable. So let me see, I don't know if I can drag my, can I drag this whole? Can drag this with me. Okay, here we go. A coefficient is a number multiplied to a variable. So 3 is the coefficient of 3x. You just have to write the number 3. You don't have to write the whole sentence. So if I was to name the coefficients, you're going to write 3. Then another coefficient, you're going to look for a variable. There is no variable. Here's the variable. The coefficient would be 2. 2 is the coefficient of x. No variable. Here's a variable. Now you need to think, what would be the number that's being multiplied to that variable? We don't always write it, and that is 1 is the coefficient of x. So you would just need to write 3, 2, and 1 in this case. Next, like terms. Like terms are terms that have the same variable. Okay? So, also, you need to know that it needs to be raised to the same exponent. So, if it's an x and an x squared, they're not like terms. They have to be the same variable, x and x, raised to the same exponent. If I look here, I see I have two x's, 3x and x. Those would be the like terms. I don't see any other ones with variables. However, 8 and 5 without variables, those are just numbers. Those are also considered like terms. So please add that in. 5 and 8 are also considered like terms. So just plain numbers are like terms as well. Okay. Constant is a term without a variable. Oh, and you know what? I messed that up back up here. This should be negative 5. When you're naming this term, you need to take the negative sign with it. Negative 5 and 8 for like terms. Constant, 8 and negative 5. A term without a variable. Okay, let's do some examples. Part 1. Write down part 1. Identifying parts of expressions. So we're going to name each one of these. I'll do one. You can do one by yourself. Terms. 4x, negative x, 2y, negative 3, and 6y. Those are all the terms in that algebraic expression. Coefficients, that's the number multiplied to a variable. The number multiplied here is 4. The number multiplied here to this variable would be negative 1. The number multiplied to this variable would be 2, no variable, and then 6. Like terms, same variable raised to the same exponent or just numbers. The like terms would be our x's, so we would have 4x and negative x. That would be one group because there's no other x's. The y's would be 2y and 6y. So I'm just going to kind of put a big slash to kind of separate them and write 2y, 6y. Constant, that's the numbers, plain numbers, would be negative 3. Okay, get all that down. You're going to try one on your own. Number 2. Okay. And we'll see if we can get someone in class to give us the answers to that. Next part, part 2, simplifying algebraic expressions. Notice the big important sign, double stars in a yellow box. When adding or subtracting, you can only put together like terms, same variable raised to the same exponent, by combining the coefficient, the number in front of the variable. Okay, example 1. 5x's plus 4x's. We have 5 of something plus 4 of that same something. something, whatever the x is, would equal 9x. You add the coefficients, the numbers in front, okay, or subtract them, whatever the operation is. Looking for like terms. Here's a like term, here's a like term. This 4 is going to be by itself. It does not have any other like terms or friends. 8n's plus, you look at the thing in front, plus 4n's, 8 plus 4, 12n, and then you have to bring this into the answer and not change it, plus 4. Notice I'm always taking the operation in front. That's your answer. You cannot simplify this any further. The n's cannot go with the 4's. Okay, now I'm stepping it up. I'm adding various operations. First, look for like terms. I have 6x and a minus 5x. I'm taking the sign in front. 6x's take away 5x's would leave me with 1x. We don't write the 1, we just write x. A 4 and a 7 are also like terms. I'm putting different shapes to symbolize like terms, if that helps you. 4, a positive 4, minus 7. 4 take away 7 is negative 3. Subtract 3. So your answer is x minus 3. All right, now I'm getting even harder. I'm throwing the distributive property back at you. Before you can combine like terms, you need to distribute. 2 times x, so bring down this, minus y. Positive 2 times x would be a positive 2x. Positive 2 times a positive 3y, I'm taking the sign in front, would be a positive 6y. Now I see if I have any like terms. Okay, x doesn't have anybody to go with, but the y's can go together. Just make sure that clicked over. Okay, negative y plus 6y, this is a negative 1, plus 6 would be 5y, plus 2x. You could also write 2x plus 5y. It does not make a difference because of the commutative property of addition. Okay, so either answer is okay. Okay, either that or that. All right, number 5. Whew, that's a lot of stuff up there. First, get rid of the distributive property. This is a positive 3 going to both of those terms. I'm going to copy down 3x minus 8y minus 3y plus x. 3x times x is positive 3x. 3 times 4y is 12y. Now I look for my like terms. X is 3x, positive x, another positive 3x. Those are all my like terms. 3 plus 1 is 4, plus another 3 would be 7x. My y's, negative 8y minus another 3y plus 12y. This would negative 8 minus 3 is negative 11. Negative 11y plus 12y, negative 11 plus 12 is a positive 1y. So I write plus y. Okay, that would be your answer. Okay, number 6. Although this one is small, this one does have quite a trick to it that a lot of kids have trouble with. Okay, you might want to put a star by this one because it can be hard. The reason why it's hard is right there because of that negative inside, right beside the 3. That means you have to distribute negative 3 to both items. Okay, this means negative 3 times y. Bring down my 5. Negative 3 times y, negative 3y. Negative 3 times 7 would be negative 21. Okay, and right here is where kids mess up. They realize it in the first part, but then the second part they bring down the plus. Now I combine like terms. There are no other y's for that to go with. So I take my negative 3y and I bring it into the answer. Then I do 5 minus 21. Okay, when you do 5 minus 21, you're going to get a negative 16. Okay, that is, for those of you having trouble in your head, 5 minus 21 is the same as 5 plus negative 21. You subtract these two and take the sign of the bigger number. And that's where that came in. All right, last one problem in part 3. We're going to find the perimeter. Finding the perimeter means that you're going to have to add all the way around the sides. Okay, adding up all the way around the sides, which is what I'm writing here for those of you who forgot, would mean you're going to have 2 of these. So 2 times 5y plus 3, plus you're going to have 2 of those, 2 times 2y. Let's simplify that. 2 times 5y is 10y. 2 times 3, 6. Plus 2 times 2y, 4y. Combined like terms, 10y and 4y are 14y plus 6. That's your answer for the perimeter of that rectangle. That's it for today. That's a lot of stuff. We will practice more tomorrow. Have a good day.